Hello, my name is Johan, and today we're going to be going over a pretty difficult ACT math question. All right, so let's get right into it. So the question says, the graph of the equation h equals negative a t squared plus bt plus c describes how the height of a baseball changes over time. The question then asks us, if we alter the c term, what other effects does this alteration give on the function? And our options are between the h-intercept, the maximum value of h, and the t-intercept. All right, so let's just start by reminding ourselves what these different parts are. The h-intercept, which I'll draw here with the red dot, just describes where the function h intercepts the h-axis. And to find that, all we have to do is set t equal to 0. Okay. The second part, the maximum value of h, is about right here. And to find that, we're going to have to transform h into its vertex form, which is given as, I'll write h equals p t minus q squared plus r. This r is going to give us the maximum value of h. Okay, and lastly, we have the t-intercept, which is going to be right down here in this blue circle. And the t-intercept just tells us, well, where does the function h intercept the t-axis? To find that, all I have to do is figure out at what point h equals 0. And this is also known as finding the roots of h. Okay. So let's go ahead and get started. We'll start with the h-intercept. Let me rewrite the equation. We'll have h equals negative a t squared plus bt plus c. Right. And as we said earlier, the h-intercept, all I have to do is find where t equals 0. So let's go ahead and set t equals 0. Then we'll get h equals c. Right? That means that c is the h-intercept. So if we change c, we are changing the h-intercept. So we'll put a check mark by I up there. Okay. Let's go ahead and go to the second part. So for the second part, we have to transform our function h into vertex form, right? And so to do that, the first step we're going to do is factor out this negative a up here. So we have negative a, parentheses, t squared minus b over a t minus c over a. All right. Now let's remind ourselves, to complete the square, all we have to do is we'll have a parentheses t. We're going to take half of this middle term, half of this term over here, and put it right there. So half of this middle term is going to be negative b over 2a. And we can close the parentheses and square it. Let me move this down just a little bit. Okay. And once we do that, we also have to subtract by the square of that term we just added. So the square of that term is going to be b squared over 4a squared, right? So that takes care of this term here. And at the end, we're just going to stick c minus a again. All right, so our last step is just to simplify everything that we have so far. So we'll have h equals, we're going to distribute the negative a. So we have negative a t minus b over 2a squared. Distribute the negative a, we'll have plus b squared over 4a plus c. Right, and as we said before, this piece right here is going to give us the maximum value of h. So as we can see, if we change c, we are changing the maximum value of h. So I'll go ahead and put a check mark by 2 as well. All right, now let's go to the last piece. The last piece was just asking us where the t-intercept was. So remember, all we have to do is set h equal to 0. And if you remember what h was, at first we had negative a t squared plus bt plus c. Setting h equals to 0, we'll have 0 equals negative a t squared plus bt plus c. Right? So we're just going to want to find the roots of this equation. Now you can use any method that you're most comfortable with. I'm going to be using the quadratic formula. Right? And the quadratic formula just says that the root t is equal to negative b plus or minus the square root of b squared plus 4ac all over negative 2a. All right. Now these are the roots, and you see that there's a c in here, right? There's a c right here. So if we change c, we are changing the roots as well. Thus, we're changing the t-intercept. So I'm going to go ahead and put a check mark by 3 as well. So our final answer is going to be 1, 2, and 3 will change. We're just going to look for that answer in the options and select it. All right, and that's going to be it for this lesson.